This video is about conducting chi-squared GOF test. First step, state HO and H1. Create a table for observed frequency and expected frequency. Use this formula to calculate chi-squared. Observed frequency minus expected frequency squared over expected frequency. Find the significance level alpha and degrees of freedom using this formula. N is the number of samples. 5. Find the critical value by using inverse chi-squared. This is a critical value. We will use inverse chi-squared to figure this k out. You could say this shaded area is 1 minus alpha. That's why the area will be 1 minus alpha. Conclusion: if chi-squared greater than k, reject HO. Chi-squared less than k, do not reject HO. Also remember, in chi-squared test, make sure all expected frequency is no less than 5, which means you have to make sure expected frequency greater than or equal to 5. Otherwise, you need to combine the expected frequency. Guided practice 1. 6 coins are toasted simultaneously 320 times with the following results. At 5% level of significance, test the hypothesis that all the coins are fair. First step, state HO and H1. We want to test whether all coins are fair. Keywords: fair. This is HO. So HO, all the coins are fair. H1 will be opposite. All the coins are not fair. Second step, we need to create a table for observed frequency and expected frequency. When you say 6 coins are toasted, which means a coin toasted 6 times. This will be binomial distribution. A coin toasted 6 times. We got 0 tail, 1 tail, 2 tails, and so on. So it will be binomial distribution. The expected frequency equals n times the probability, n equals 320, times. We will use binomial PDF. Toasted 6 times. The probability of getting tail for a fair coin is 1/2. This x will be 0, 1, 2, 3 until 6 separately. We will use this formula to figure out the expected frequency. Let's go to this scratch pad. Menu 5, distribution 5 again. Binomial PDF is A. N is 6. Probability of getting tail is 1 divided by 2. X value, start from 0, enter. then times 320. We get 5. Go up, enter. Change 0 into 1, enter, times 320. We got 30. Go up again. Change this 1 into 2. Times 320. Enter. 75. Go up again. Change this 2 into 3. Enter. Times 320. Equals 100. Keep doing the same process until you change this x into 6. Then you can record the answer. 5, 30, 75, 100, 75, 30, 5. The third step, you need to figure out chi-squared equals summation of observed frequency minus expected frequency squared over expected frequency equals. We got to use a spreadsheet. So click on, go to 1, new document. No. 4, spreadsheet. Let's label the first column FO as the observed frequency. Second column FE as the expected frequency. Then type in all the data for observed frequency and expected frequency. Then go to the third column. Let's label as P. Go to this formula bar. Double click. Then type in the formula, parentheses, go to variable, FO minus, go to variable again, FE. Squared, divided by, go to variable again, FE, enter. We add all the values in column P will be the chi-squared value. So move the cursor into an empty cell. Go to menu. Go to 3. Data. Go to 6. List math. Go to 5. Sum of elements. Go to variable. Pull out this P. Enter. We got this answer. 2,173 divided by 300. Let's check whether this answer is correct or not by finding p-value. Go to menu. Go to 4 statistics. Go to 4 stat tests. Go to 7 chi-squared GOF test. Observed list will be FO. Use the right arrow button to get FE for expected list. degree of freedom. There are 7 data for observed frequency. 7 minus 1 is 6. Then enter. We got chi-squared value equals 7.24333. We got this chi-squared value is a fraction. Let's check are they the same. Go to this scratch pad. 2173 divided by 300. Enter. Then Control Enter. Change this into decimals. 7.24333. Chi-squared value is correct. When you write down your answer, remember you need to copy down all the values from this column P. Equals 7.24. The fourth step, we know alpha equals 0.05. DF, count the number of data 1, 2, 3, 4, 5, 6, 7. 7 minus 1 equals 6. Then we can figure out critical value K. We know K equals chi-squared 1 minus alpha df equals chi-squared 1 minus 0.05. df is 6. K equals chi-squared 0.95. 6. We will use inverse chi-squared to figure this out. Manual. 6. 5 distribution. Inverse chi-squared is 9. Area 0.95. Freedom 6. Enter. 12.5916. Then last step, we need to draw the conclusion. If chi-squared greater than K, reject HO. P-value less than alpha, reject HO. We got chi-squared is 7.24. K is 12.5916. Symbol less than. Not enough evidence to reject HO.